So today we can see what is this cloud all about and how it started and what are the different opportunities, new opportunities that are created by this cloud systems and how we can use JavaScript in various roles or in various parts of this cloud-based application. So let me introduce the topics that we are going to see today. So we'll see before cloud how the systems were built. We call that as legacy systems in this context. So how the legacy systems were there, what are the disadvantages of using legacy systems, and why people actually thought of moving to cloud. So those things we can see, and then we'll see what is a cloud system, how does the various components in the cloud system interact. In a higher level, we'll see what are the components, what are the different types of cloud-based applications, and such kind of things. And then we'll see about advantages of cloud, and then we can see about so this particular webinar is more concentrated on JavaScript. So we can see about how we can use JavaScript or how learning a single language JavaScript will uh, help us to get different roles in cloud-based projects. And then we can see a simple demo of how we just write a HTML and a JavaScript and how that gets rendered in the browser and executed and so on. And we'll see the various job opportunities by learning JavaScript and other cloud technologies. So here we have like legacy systems. So what we call as legacy systems here. So before we had cloud, what people used to have is like a network of computers. So they will have an network within their organization. So the data inside the network cannot be accessed from the outside. So you have the data stored within their network, and it is accessed through the systems that are connected to the network. So what we have to do is we have to have the system on premise. So you'll have all the servers, the application server, the database server, everything within the network itself. And it is the duty of that particular organization or that particular client to provide the necessary infrastructure, and they have to maintain that. So it becomes the duty of that particular user itself, and they need to take care of the hardware requirements. So when we take legacy systems, what happens, we might be having using some kind of software which needs some kind of hardware. Say it might be about a simple example is like the amount of RAM that we need or the amount of ROM that we need for a system to run. So even from the basic things like from electricity to till this RAM ROM configuration, everything is at the everything should be taken care by the user. So they have additional overhead, like they have to take care of the system and then they have to use the system as well, and the data is available within the network. So there are two aspects in this. One is a positive aspect where the data cannot be accessed by someone outside the network, and the second negative aspect is if you want to take the data, you are somewhere else and you want to access the data, still you will not be able to take. So these were like, this is how the legacy systems basically were working. So even now if you go to some banking systems, you find like they would be working with a black screen. So they will be interacting with the black screen and they will be typing some commands. So that would be retrieving the data from within the network. So that is how it used to be. So you will have a interface through which the user interacts. So that interface connects to the database and it fetches the data and it shows to you. So that is how the legacy systems were. So what are the disadvantages of this legacy system? So the first thing is it is not friendly to access from outside the network. So everything is hosted within the network. So if suppose you're like you forgot something and you went to your home, you want to access some data, you will not be able to do. And then you have only your mobile device. You don't have like a laptop through which you can connect to the network. Still, you will not be able to take the data. And chances of data loss. So they have to be very careful about maintaining the data, taking frequent backups, and for that they will have another set of hardware and software requirements. So this complicates the overall process. So what happens is when I build a software and give it to them and they host it within their network, they have to take care of that. So they have to do the maintenance and everything. So it is a overhead on the user. So if suppose I go to client 2, again client 2 will have like different set of configuration. So it becomes a overhead for me as well. So they will tell like, I have only this set of configuration, you build and give me a software which matches this configuration. So at the end, I will be building multiple copies of the same software that I am trying to build. So that is one disadvantage with legacy systems. And then downtime during maintenance and software upgrade. So if they don't, if they want to do a software upgrade, then they should have a backup mechanism. If there is no backup mechanism, then they will experience a downtime. So all these overhead will all these things will create a overhead both for the user as well as for me as a software developer. So what they thought is, let us remove this difficulty for the user, let us maintain all the infrastructure, and let us allow the users to access our software from anywhere. So that is where they thought like, oh, then we have to take the system from within their network and put it in some common location from where they can access. And I will go and update the common location. I will maintain the hardware and software requirements that is needed in that common location. And then I will actually take care of this downtime. I will take care of the data. I will take care of the data loss. I will do a frequent backup mechanism. I will do the maintenance on my own, like that. So that is where people started thinking like, how we can build such systems. That only has led to this cloud computing. So in cloud, what we have is, basically we have like two parts in a cloud based application. We call it as a client and we call it as a server. So the client is nothing but with which the user will interact, and the server is nothing but uh, the server will actually connect to the database, and it fetches the data and gives back to the client. So this is the simple architecture of a cloud based system. So in any cloud based system, you will have three components. You will have a client, you will have a server. Within a server, you will have two main components: application server and database server. So that is how a cloud based system is built. So when you see cloud, when you tell cloud, so how, where is, so a simple example that we take is Gmail. So now you have Gmail, you are able to access Gmail from anywhere. So you are able to access Gmail from your desktop, you are able to access it from your mobile, you are able to access it by installing an application. So you have a Gmail app from the Play Store, you install that, and then you access the Gmail application. And then you can access it from anywhere. So you can access it from your home network, you can access it from your office network, college network, or mobile data as well. So that is the flexibility that cloud is offering. So you are able to access your data from anywhere, and to access that data, you don't need anything except an internet connection, right? So you are not going to maintain any hardware requirement or software requirements. The simple thing that you need is if you are using a web client, you just need a browser. If you are using a mobile client, you have to go to the Play Store and download the app, and you have to just install. So that is all what you need to do. But the hardware requirements and the software requirements, the maintenance, downtime, data backup, everything is taken care by Google. So they take care of everything, and they give you a simplified experience. So you get an easy experience of using that application. So that is the main advantage of cloud-based systems. So you don't know where the server is hosted, right? So what you see actually is called as the client. So you are going to browser, you type gmail.com. So what happens? A web page gets loaded. You see a page gets loaded. And then they ask you your user ID and password. So when you type in your user ID and password, then you will see, then you will be able to see your mailbox. So this is a simple example for cloud-based systems. So what happens? Where is the data? Where does the data get stored? From where your data is coming, how it is interacting with the server. So everything happened behind the scene. So what you basically see is a simplified experience. What they tell you, you just go to gmail.com, you type in, you just open your browser, type in gmail.com, the web page gets loaded, and then you enter your user ID and password, you enter the application, and then you use it, and then you sign out. So that is a simplified experience that you are getting. You don't know what happens behind the scene. So that is, That is the basic thing that cloud systems are offering us. So what happens? Why do we need the user ID password? So the main thing is all the data now gets stored in a common system, right? So whether it is your data or my data, if it is Gmail, that gets stored in a common system, common database. So they don't have separate databases or separate networks for each person. So they need a way to identify you. That's where they need a username and a password. So when you enter your username and password, the client will send a request to the server. So from the client, what happens? A request is invoked. That request goes to the server. In the server, it receives that request. It extracts the parameters. For example, here the parameters are username and password. It takes the username and password value from the request, and then it connects to the database. So the client cannot connect to the database directly. What happens if the client connects to the database directly? I'll be able to see everyone's data. That is not correct, right? So yeah, you have uploaded some confidential mails. You have sent some mails in a confidential way that should not be accessible to other person. That is all data privacy, right? So the client cannot talk directly to the database. So the server actually takes care of what data can be accessed by which person. So the client basically sends a request to the server. So here we have two things: application server and database server. So the normally the application server is called as server, and the database server is called as database itself. Okay, so you send the client sends a request to the server. From the server receives the request. It takes the parameters username and password. It connects to the database. So while connecting to the database also, you need the user ID, password, and everything. So that information is known only to the server. So the server only can connect to the database. It will go and validate whether that username and password is correct. If it says it is correct, then what happens? The server will tell the client, you now this user is correct. You now point him to the inbox. So now what happens? The request goes to the page gets redirected to your inbox. So when you log in, what happens? Some identifier. Okay, so who you are. Some identifier is given by the server to the client. So with each request, the client will be sending that particular identifier. That identifier is like some ID. Okay, it might be like your employee ID or a college ID, something like that, with which you can be uniquely identified. So the client will send each request to the server with that ID. From that ID, the server will know what kind of data he can see. Okay, what are the data he can see? What is the mail that he has sent? Only that can be seen that by that person. What is the mail he has received? Only that can be seen by the person. I cannot go and see a mail that is sent by some other person to some other person. I can only see the mails that I have sent or I have received. Okay, so such kind of code or logic is written in the server, and it fetches the appropriate data from the database, and it returns back the data to the server. From the server, the response is returned to the client. So that is the overall flow that is happening in the cloud-based systems. So uh, so what are the advantages of using this cloud? So what are you worried about? So the main thing we are what you should worry and what you need not worry. So what I need not worry is I need not worry what happens here. Okay, because this is all not maintained by me. So this is all hosted somewhere. For example, when I say gmail.com, what happens? You would have heard about DNS, right? So domain name server. So when you give the domain name, it will give you the IP address. So you will get actually it gets the IP address, and the request now goes to that particular IP. So in that IP, our server will be running. So all these things will be taken care by the service provider itself. So here Google is the service provider. So they only provide us this Gmail service. So Google will take care of everything. So whenever you are using a cloud-based application, you need not worry about how the systems in the backend are working. Okay, so I will just log in and I will start using the system. So what I need to worry is I should get this client. Okay, so only the client is the one that is in my control. So whether it can be a mobile client or it can be a web client. So most often, if you see, most people are using web clients only. They use most of the applications. Even if you see a lot of applications from the government, they are all like built as web applications, so that you don't need any additional software. So what you need is just a browser. You need a Firefox or a Chrome or some latest browser to access their application. Apart from that, you need not worry about any other specific software or hardware requirements. So what are the advantages of moving to this cloud? And what are all the various areas in this cloud-based cloud computing? So the first thing, the benefit is cost reduction. So cost reduction in the sense I need not maintain the hardware or the software requirements. Everything will be taken care by the service provider. And in the service provider context, he is also reducing a lot of cost. How is it possible? Because I'm building a solution. Okay, so I can give it to organization A, organization B, organization C, organization D, everyone the same product. I need not build separate products for each customer. I'll build a product and everyone can log in and use my product. They can sign up. So the first process you do in a Gmail is just sign up, and then you start using your Gmail product. So everyone can actually use Gmail, right? So the Gmail is not restricting anyone from using it. So everyone can use Gmail. So what happens for Google? The cost reduction in the sense they need not build separate product to separate customers. They build one product and all the customers can go and use that product. So in the client perspective or in the customer perspective, I feel like I need not maintain the hardware or the software requirements. Even if or the data backup mechanism. So what happens in Gmail? They frequently take a uh, take a data backup. Okay, so whenever the data is lost, they will restore that, and then whenever they want to do some kind of maintenance, they will take care of that. So everything will be taken care by the service provider itself. And then ease of use. So you don't need to install anything separately, right? So you just need is a simple browser. From a simple browser, you can go and access their systems. That is one way. Or the other way is through the app. So when you go to an iOS Play Store or an Android Play Store, you can download the app and you can install that. Through that, you can use their application. Okay. So these are all like simple benefits. And then with this cloud based systems, there are like basically three types of systems. Okay, so you call it as IaaS, PaaS, and SaaS. So IaaS is like infrastructure as a service, PaaS is like platform as a service, SaaS is like software as a service. Okay, so if you see now, there are a lot of SaaS companies all over India. Okay, so SaaS companies are basically like product companies. You see, Google is a they provide like lot of SaaS products. So SaaS is nothing but software as a service. They provide lot of softwares. You can log in, sign up, log in, and use the service, and you have to pay a certain amount for based on your subscription. So that is what you call it as SaaS products. So if you take in India, you have a lot of SaaS companies like Zoho, Freshworks, and then yeah, so and a lot of other SaaS companies. Apart from that, you have Google, Facebook, Microsoft. These are all like SaaS companies. Okay, so they basically what they do is they build their products and then they put it in their cloud systems. So you can just log in and start using that system. So that is what we call it as SaaS. And then PaaS is like platform as a service. So they provide platforms. So when I build a product, okay, so I have to go and put it somewhere. I have to run it somewhere. So whenever I build a product or build a software, to use that software, I have to run that software. Okay, so then only someone else can go and use that software. So where will I run that software? For that, I need I need some providers. Okay, so they provide me the provision to run my softwares. So that is what you call it as PaaS, platform as a service. In platform as a service, basically the leading platform as a service is AWS, Amazon Web Service. So what we generally do is we sign up with Amazon and we pay some amount or on a subscription basis. They will give us one virtual system. So you log into that virtual system and you go and run your program. Okay. So whatever request comes to that IP, our program will actually start responding to those requests. Okay, so that is one area. That is a very big area. So in that, the leading cloud provider is AWS, and then you have GCP, and then you have DigitalOcean, Azure, and Alibaba, like that. Okay, so you have like a lot of providers there as well, but AWS is quite leading there. And then IaaS is like infrastructure as a service. So these are like different types of cloud systems we have. And then the features of cloud-based systems, the first thing is elasticity, and then reliability, virtualization, and everything. And then apart from this, you have like scalability. So sometimes 10 users will use the system, sometimes 1,000 users will use the system. Suppose you see like Flipkart is announcing some kind of $1 billion day, something like that. In the day, if you see, so many people will be hitting the service, right? So many people will start using the application. And similarly, a simple use case previously was with our railway booking system. So if so many people during the festival time, they go and try to book a ticket, what happens? The server goes down. Okay, so now I think it is better. So now they have come up, used a lot of technologies, cloud native technologies, and they have actually made it scalable. So but from the starting, if you see this Amazon, Flipkart, everything, they were built scalable. So when the request is high, they will be increasing the number of resources or the software and the hardware requirements. When the usage is less, they can decrease that software and hardware requirements. It is as simple as that. So cloud will basically give us the provision to do those things as well. So these are like advantages of cloud we have.